Okay, hello. I want to talk to you about HTTP Toolkit, which is an HTTP tool I've been building. We're going to look a little bit at what that does, and then a lot at how that intercepts HTTP in Python, how that gets involved with some of the Python internals, and plays around with them to take over all HTTP and HTTPS, and do some neat things with it. This is going to be a bit useful. There's some neat tricks you can do with this in various other cases. Partly an excuse to just look at how some low-level details of HTTP and Python work internally, play around with some of that, and partly just quite cool. It's quite fun being able to play around with a lot of this stuff. So to start with, HTTP Toolkit, what is it? It's an open source cross-platform debugging tool that I've been building. It lets you interact with and capture and see all HTTP and HTTPS. HTTP is pretty much everywhere now. Anything you're doing, if you're building web applications, you're delivering the whole application and then all communication over HTTP. If you're building servers, you're talking to other services through HTTP APIs. Your error reporting, your analytics, your payment processing, your maps, everything runs on HTTP. If you're building DevOps scripting, all of that is talking to the Amazon APIs, is talking to GitHub, is talking to Slack, whatever, all through HTTP. So HTTP acts as the fabric that's connecting pretty much everything we're building as software developers. And the goal here is to let you see that fabric, see that underlying layer that glues everything together, and play with it, change it, interact, edit things live as they're happening. What does that look like? Let's have a quick demo. So this is HTTP Toolkit. It's got 3 sections. You can intercept traffic, you can look at the traffic and inspect it, and you can add rules to rewrite and change traffic. The bit we're interested in, that I want to play with here, is intercepting Python. So you click this button and it opens a terminal. This is just like any other terminal on your computer. You can do anything you like, just like normal in here. We're going to run Python, and then from here we can run anything, and it'll immediately get intercepted. Let me move that. So let's try requests, for example. Who's used requests as a library? Popular HTTP library? Great. So we can take this, and we can make a request to example.com, and just like that, we've collected traffic. So this starts coming through here, and you can see that request sends things with these details, and responses come back like this. So there's no setup here whatsoever, and the goal for all of this is to make it as easy as possible, which adds some interesting constraints. I want to be able to capture Python traffic without installing any dependencies at all, without changing your code in any way at all, without needing administrator privileges or any of that. I want to totally invisibly, with zero setup, intercept all traffic. And this is HTTPS, notably, so it's, in theory, encrypted and private and uneditable and everything that's not happening. So that's requests, but we could also do more interesting things like use the built-in Python 3 libraries. So I can try and write this blind and see if I can do it without making any mistakes, which I have not. Yeah? No. Connection. That's it. Nice. Okay, and then we go like this. And again, requests start coming through immediately. We can see what's going on here. And we can also rewrite this. So let's say, hey, all requests that go to example.com. I'm just going to pause them, breakpoint that. And then if I go here and we go back to requests, this stops here. You can see before we got 200. Now we don't have a response yet. We can go in and say, spit out a 404. And resume. And then Python gets a 404. So totally automatically, we can collect traffic, we can rewrite traffic, we can do whatever we like, errors, blah, blah, blah. This does Python, but then, hey, we can do curl, and you pick up that. We can do even searching with pip or something like this. So, do this, and now we can look at how the internals of pip work. Pip sends its requests, and thousands of lines of XML, which is great. But you can start playing around with all these tools, and all this stuff just comes through automatically. So, yeah, this is quite cool. With zero setup, we're able to dig inside Python and automatically capture all of this traffic that, in theory, is private and encrypted and uneditable and unchangeable. All of that comes through totally miraculously with no effort. This is a bit complicated, but being able to do this kind of thing not just allows you to rewrite HTTP if you want, but with the same techniques you can rewrite anything. So we can capture anything that's going on inside a Python program. Let's start. That's what that was. Let's start with HTTP itself. Okay? Normally, it looks like this. You want to talk to example.com. With plain HTTP, you send a request. Example.com sends a response back. And if you look at the actual data that's being transferred, that looks like this. You send a method and a path and maybe some headers, including the host of who you want to talk to, and you get back a status and maybe some headers and a body. You ask for hello HTML, and the server says, okay, I've got some HTML, here's the HTML. This is HTTP 1. HTTP 2 is effectively the same concept. The actual data getting transferred changes, but all the concepts are structurally the same. We send requests with this data, we get responses. If you want to intercept this as a proxy, it's pretty easy. You make the client send the request to you instead, and then you have the raw data. You pass that raw data straight on to the server gives you a response back, and you pass that back to the client. And you have this data coming through here, and from this you can see what's going on. You can change that before you pass it back to the application, and so on. So for plain HTTP, this is pretty easy. HTTPS is more complicated, to say the least. What you expect to happen is something like this. You want to talk to somebody, perhaps your bank, anybody else where you want to talk to them securely, realistically, in the modern world, anybody you want to talk to, and you set up a connection that is secure, that is private, that other people can't edit and can't see inside. Your requests and your responses should be encrypted and unreadable, uneditable by anybody else. If you try and put a proxy in the middle of this, what should happen is you can't. You can't do the kind of thing we're looking at before. You can proxy the traffic through, but only as a tunnel. So the proxy sets up a connection which just passes your content straight through and cannot look inside and get involved with the data itself. That looks something like this. The application connects to the proxy and says, I want to connect to this target website. Effectively, I want a tunnel where I can send raw data through to that domain. The proxy says, sure. And then the client sends whatever it likes, which goes directly to the target site. So it starts from scratch and creates an HTTPS connection to the target site. What that means is it says, hi, I want an HTTPS connection to you. Can you give me a certificate? Mi Banco comes back and says, here is a certificate proving that I am Mi Banco, signed by a certificate authority you trust, which is what allows it to know for sure that it's talking to the right person. And as part of this process, they also agree some encryption keys that ensure that the rest of this traffic is unreadable by anybody else up here. It's just encrypted data getting sent through the proxy. And the proxy can't see what's going on inside of it. What we can do, though, to start digging into this data, is to lie as the proxy. So rather, when the client asks to connect directly to a site, instead of passing their data onto that site, we just pretend to be that site. So I, as the proxy, generate a certificate, and I write Mi Banco on it, and I give it straight back to you. If you're the app and the real server is over here, I accept your request and I respond directly and start an HTTPS connection with you. This looks more like this, and much more like a normal HTTP proxy session. You connect to me, I set up HTTPS with you, I set up HTTPS with the bank, and then I read the requests and pass them on, read the responses and pass them back. This doesn't work. If I try and do that, if I make a certificate and I promise that I am your bank, and I give it to you, you won't believe me. I can't do that, and it's important if I can't do that, because nobody should be able to pretend to be your bank. The way that works is that you have certificate authorities in your computer, in applications built into all software you use, which are specifically trusted. There's a list of people who are allowed to issue certificates. People like VeriSign, people like Komodo, various different trusted specific authorities. And if the certificate is signed by them, your application will believe it. And if it's not, if it's just signed by me, they won't. They will reject it and say this is not real. But that is the only constraint here. So if I can somehow get the application to trust me as a certificate authority, then I can do this. So I, within the proxy, say, I'm going to generate certificates. You should trust me to generate certificates. And if I can persuade you that you do trust me to generate certificates, then I can proxy all traffic to anywhere. I can write certificates to be whoever I like, and you'll connect to me and think that I'm the bank, and I'll connect to the bank for you, and I can see all the traffic and pass back and forth, as if it was plain text like before. Does that make sense so far? People more or less with me? Yeah? Okay. So, what do we actually need to do to intercept HTTPS? Those two things. We need to make the traffic go via the proxy, and then we need to make the client trust the proxy as a certificate authority. Trust the client, trust the proxy to write certificates for any domain all by itself. And if we can do that, we can intercept HTTPS, and we can see all the traffic and rewrite all the traffic and do whatever we want. So this is the goal. How do you do that in Python? This is where it gets interesting. Firstly, environment variables. Environment variables are really interesting in that they're inherited. If I start a process with some variables set, and it starts another process, then both processes will have the variables set. And that goes on down the chain. If I start, for example, a terminal with some variables set, every application that the terminal start has those variables set. And if that terminal starts Python, and that starts curl, and then that starts, and so on and so on, all of those have these variables set. So everything gets inherited right the way down the tree of anything you run. Which means if I start the terminal and I set these two environment variables, which set the default proxy for most applications, then for most cases, I already managed to reroute the traffic. So that's the first of the two things we need. The traffic comes to my proxy instead of being sent directly to example.com or whoever. And then I need to somehow make it trust the certificate authority. And there are some environment variables that help a bit with that. So for anything using OpenSSL, which is a very popular, is maybe not the right word, a widely used SSL library, TLS library, for certificate management, that has an environment variable, and if it's set, it will use these, it will trust the CA specified, the certificate authority specified in that variable. So we can set a variable, and everybody using OpenSSL will immediately trust us to handle certificates. And requests as well has its own variable. So if I set this, and the proxy, which requests uses, I immediately get requests straight away. Those are the two things we need. Unfortunately, that's not really enough. These environment variables are reasonably widely supported, but I want to capture everything. I want all HTTP, all HTTPS. And lots of tools and libraries don't listen to the settings we're talking about here. So we need to go a bit further. With just those settings there, by setting those on the command line that opens, I get requests, and that's great. But HTTP lib, which is the built-in Python library for Python 2, doesn't work. That ignores all of those settings. HTTP lib 2, which is a published package that tried to improve on that, ignores the CA settings, and doesn't have an environment variable, but does use the proxy settings. http.client, which is the Python 3 option, doesn't listen to any of this again. And then other specific libraries like Stripe do all sorts of interesting things. In this case, they include their own CA file, and those are the certificates they trust and nothing else. So we get all of these weird and annoying special cases, and I want to somehow make all of these do the right thing. Fortunately, lots of other people want to do this as well, so most libraries have some kind of feature requests or discussion around these sort of features, and in the nice cases, they come up with actual solutions. So Stripe, for example, has a property in Stripe, which if I point to my CA, will make it work. So if, when you run Python, I can automatically set stripe.ca bundle path to point to my CA, then Stripe will trust me, and I can intercept Stripe, and we can see all of this traffic going back and forth, which is really nice. So, how do we actually do that? At this point, we're not just setting environment variables around all applications and trying to capture everything. We're trying to dig into Python specifically. When you run Python, if you use Stripe, I need to reconfigure it so that this property gets set before any of your code that uses Stripe actually runs. That's an odd thing to do, but it's possible because of the way that Python modules are imported. So, how do they actually work? How does Python actually load modules? It does something like this. When you run import Stripe, it looks at sys.modules, which is a dictionary that maps module names to loaded modules. So every time you import anything, it gets cached in that dictionary so that it only gets imported once. If you import the same thing twice, the second time it just comes out of that dictionary already loaded. Okay? If it's not in that cache, it loops through sys.path. This is a list of strings, a list of paths on your machine, and it looks in each path there and tries to find the module in that location. So these will be perhaps your virtual env, this will be the packages installed on your machine, this will be the built-in packages of Python itself. One by one, it will step through these, and if it finds the module, it loads it, it caches it in sys modules so that later requests don't have to load it, and then it returns it. And if it loops through all of the paths and it doesn't find anything, it throws an error and says, cannot import module. This is the overall structure. There's a lot of interesting Python hooks and ways that you can play around with this, but in my case, I want this to work in Python, all Python. In Python 3, in Python 2, in every version of every Python I can find that anybody is using. It would be great if this just worked out of the box. So whilst there's other interesting, complicated features like import lib in Python 3 that lets you add hooks into places in this, I don't want to use that. I want to interact directly with this process, which is the core part of Python module loading. How do we do that? So sys.path is the interesting bit of this. That tells Python where to look for modules, and that is set by default to the value of Python path, which is an environment variable. So we can set that. We can control before Python starts where it's going to look for modules. What that looks like is that we make a folder, let's call it overrides, and if I put a file in there, like stripe.py, and then set Python path so that the overrides folder comes before all of the rest of Python path, then when you run import Stripe, it'll import my Stripe rather than the real one. And you can turn that on just by changing the Python path. We don't need extra dependencies, we don't need any extra code in your application. You just need to set this variable so that Python looks in a different place for modules. And then in that Stripe file, what we want to do is import the real Stripe and change it slightly and set this CA. So we just tweak exactly how that module works. Unfortunately, this has a problem because if I override Stripe, I can't import the real Stripe. All of a sudden, I'm in this horrible problem where everything is going to fall apart and real Stripe becomes inaccessible, which is going to be very expensive. What I need to do instead is somehow get at the real module underneath. To do that, we're going to need something like this. In our override module that replaces Stripe, when that's loaded, we need to unreplace Stripe, go and get the real one, so that then import Stripe gets the real Stripe. This sounds kind of crazy, but it turns out we can do this. It looks something like this. So what we actually do in here, all this code is open source, by the way. If you want to go and have a look through it, github.com/http Toolkit has everything, and within the server there's all these override bits and pieces. What is this doing? So firstly, we work out where our overrides are stored. Because this is running on lots of different people's computers, on Windows and Linux and Mac and all sorts, I don't know where the override files are. So instead, we just say it's whatever folder this override script is running in. And that's what that does. We get the absolute path for the current file, and we find the directory that is, and we use that. That is where our overrides live. Then we take that out of sys.path. So we set up this Python path thing, which allows us to add an extra directory that modules get loaded from, and then here we remove it again. So we temporarily disable our override, then we go into system.modules and uncache the module, kick out our fake Stripe, re-import it, which now re-imports the real one because we've unset the override, and then we put syspath back and put the override back into place. It is crazy, and it is ridiculous, and it works. So with this put together, you can do this sort of interception for every version of Python, everywhere, for any module. You can take this and Python path, and from outside Python, you can wrap and replace anything, which is quite fun. So this is what the actual Stripe replacement code looks like in HTTP Toolkit. So this is included in the app. And all it does is set Python path so that it points to this directory. When you load it, you load this Stripe instead of the real one. This then loads the real Stripe, edits it to add RCA, and then gets the public properties and also some of the private properties so that from the outside point of view, this acts exactly like the real Stripe. It's got the same path, the same file as the real Stripe, it's got the same doc string as the real Stripe. Everything looks just like real Stripe. And just like that, we completely take over the module, and now Stripe trusts us, and we can intercept Stripe, or anything else we like. Let's try another one, HTTP lib2. Slightly more complicated. At the top, we do the same thing where we reload HTTP lib2 and re-export all the stuff, and then we start replacing some more complicated parts of it. So for HTTP lib2, it's got this HTTP class, and the constructor of that is what controls which CA it trusts. Unfortunately, it won't let us change that externally, so we're going to replace it completely. To do that, we grab the original constructor, we make a new constructor, and we replace it. And then in the new constructor, we look at all the arguments and try and work out if you specified a certificate anywhere in various different ways, and then we throw away your certificate and put ours in instead, and then we call the original constructor. So we wrap the whole thing, replace it all, and miraculously take control of this. And the last neat trick in here is functools.wraps, which is part of the Python standard library, and copies lots of the common properties that you'd want on a function onto this replacement function. So things like the name and the doc string and so on get copied across. so that from the outside, the HTTP constructor looks exactly like the real one. We do this little trick where we swap this out, and all of this happens quietly and automatically anytime you run import HTTP lib2, silently under the hood. Okay, last one, http.client. This then gets slightly more complicated. If you want to be able to intercept cases like this, where you have a module inside a package, things get difficult because HTTP also contains other things. There's http.server, there's http.cookiejar. Even import HTTP has its own enum just within the root package there. And we need to not break any of that while still intercepting the client. So to do that, to intercept http.client without breaking the server, we need to create a whole fake package that then only replaces the client. Part of that is relatively easy. So we create an init package, init module, a root part of this package to fake HTTP. And in there we load the real HTTP module immediately. And ensure that, because when you run import http.client or import http.server, what it actually does is import HTTP and then import http.client. So if we can hook into the first stage of that, we can fix it so that it works for either case or anything else. If they add more modules to HTTP later, those need to keep working as well. So the actual code to do that is relatively easy. In the init, we say, if you ever import anything from HTTP, we hook into the client immediately, because we need to guarantee that that gets correctly injected into as soon as possible, so that we don't accidentally end up with real HTTP, which would be a disaster. And then in the client, we do slightly more complicated but similar things to before. This is as complicated as it gets, I promise. So let's go through this. Yeah, so at the top, we reload the real HTTP and HTTP.client. We do both because we've got these multiple tiers. Things get complicated and confusing. But we have to reload the real HTTP first. And then we do similar things to the previous bit before. So we replace the constructor for plain HTTP so that it rewrites wherever you were trying to go to instead be the proxy, and then tunnel through the proxy to whichever real site you want to go to. And again, we set up functools so that all of this looks just like the normal HTTP constructor. And then for HTTPS, we do basically the same thing. We get the certificate, we create another fake constructor, we inject the certificate, our fake CA certificate, over the real one, throw away all your real certificates, we tunnel across the proxy once again, and we replace the constructor for HTTPS. This is about as complicated as it gets, and it's still, you can just about fit that on a slide, more or less. So this isn't too bad. And with this, even for quite complicated cases, nested packages, weird, interesting, wonderful things, you can completely replace and dramatically change behavior. Once you've got PythonPath, so if you can set environment variables, and you just use this quite short preload function and functools, you can completely simulate any module. This is quite useful for me, because I want to replace bits of HTTP in all sorts of random programs in all sorts of interesting ways, but it's also useful for other things as well. So if you want to set up testing, for example, you can create some mock versions of modules, and you can enable test mode or not entirely by just adding something to PythonPath. You can replace modules with test versions. You can swap out Stripe with something that doesn't make real requests to Stripe. Whatever you'd like. You can do interesting bits of logging where you inject extra logging into modules automatically, potentially for every single different kind of Python project you have, just by setting PythonPath on them when you start them, or not setting it, and using that as a toggle. And this sort of technique lets you do some really interesting things to play around with the internals of Python, mess around with exactly how modules work. The challenging part is that then I also have to do this for Node.js and Ruby and PHP and every browser and Android and Docker and so on and so on and so on, which is another talk. But it turns out you can pretty much do the same kind of thing for everything, step by step, in slightly different ways, but pretty much the same techniques works. And that's a lot. It's ridiculous, but being able to dig into this gives you some really, really cool and interesting techniques. And the end result, where you just click a button and then run anything and it works, is incredibly powerful and a really useful way of exploring this kind of data. That's everything I've got. I am PinTerry on Twitter, and I'll put the slides up in a minute, and I think we're going to have a video and a recording as well on Meetup. Hopefully that's interesting, maybe useful, or just crazy. But yeah, that's all. Thank you. Does anybody have any questions?
Yep.
Yes.
Thank you for your talk. Very interesting. The byproduct of your talk was basically that Python is incredibly unsafe. And my question is, consider Spark, for instance. What would you do to actually harden it?
It's in Python. It is effectively, especially at this stage, some of the fundamental decisions in the language allow you to rewrite anything and inject into lots of places. And things like PythonPath are intentionally designed there to change which bits of code get loaded. So from Stripe's point of view, there's nothing they can do about this. And what it instead means is that if you're running Python, you have to, for example, be sure that nobody else is setting environment variables on your server. Because if they can do that, they don't even really need to be able to write many files or anything. They just need to set this one variable, and they can completely, dramatically change how your system works. So from Stripe's point of view, I don't think there's anything you can do. From a Python deployment point of view, I think it mostly just means you have to be even more cautious about how you allow access to your servers.
Thanks.
Anybody else?
Tim, thank you for presentation. The question is about maintenance of HTTP Toolkit. So if, for example, with libraries you have faction changes over time, how difficult for you to maintain the toolkit?
Yeah, it could get difficult. At the moment, it's quite easy because most of these libraries don't remove features that much. Certainly basic things like proxying and how you control the CA isn't something that people really want to iterate on and make new versions. And a lot of them actually don't think about this at all themselves. They delegate it to a built-in HTTP library or requests, and if I change that one library, everything that uses it magically works. So it's not too bad. In theory, if that did happen, I can inject into any module and do arbitrary logic. So I can put some code in the module that says, if this is version 3, if this method exists, do this. If it doesn't, do that. And potentially, at the moment, I think this works for pretty much any Python code, but it's totally possible that new modules will come out that this doesn't support yet, but I can add another file in for that module and wrap that module and do something and build on it from there. So it's quite flexible.
Okay, thank you.
Thanks. Yes?
Like I've seen you played with several languages, like with Ruby, JavaScript, Kotlin probably. Have you seen any language where you can do that?
The hardest one is Android, really, actually. And there, the difference is not so much in the language, it's that the operating system is integrated into how the language works. So, as of Android 6, 7 maybe, a relatively recent Android, they changed it so that if you install certificates, the applications don't trust them anyway, unless they specifically opt in. So I have some awkward cases there where you can, if you're trying to intercept your own Android application, it's really easy. You add a line of config and everything just works. If you want to intercept somebody else's Android application, on standard Android, you can't. You need an emulator or a rooted device or something like this. So you need other tricks to work around it. And that, yes, sort of speaks to your question, how can you harden these sort of languages? When you integrate the operating system so that it is opinionated about about how certificates work, about how HTTPS works, it makes a lot of these techniques impossible, or certainly more difficult? Good question. Anybody else? Okay.